Today, in part 1 of this video, we'll be taking you through the Peel.3D scanner workflow, including part preparation, setup parameters, scanning, mesh cleaning and editing, and entity creation for reverse engineering. In part 2, we'll look at how you can use those entities to streamline your CAD modelling, making the reverse engineering process smooth and painless. The new Peel.3D scanner is lightweight, at just under 1 kilogram, and features an array of upgraded cameras and sensors to help capture part surfaces quicker than ever. We have geometry and surface cameras at the top and bottom, surrounded by infrared lights, which are used to see the targets placed on the object. In the centre, we have a ring of LED lights to illuminate the part's surface, and a texture and colour camera for scanning in full colour. Finally, we have an infrared projector which projects a series of lines over the object, which are reflected back and allow the scanner to determine the distance to the surface. On the back, there's a touchscreen which gives easy control of zoom and exposure settings. The scanner has 2 ports, a USB port which connects to your laptop and a power port which leads to your mains socket. Your scanner can be calibrated in seconds and will ensure that it's capturing the geometry with optimal accuracy. A single calibration can last up to 7 days, providing that you're scanning in the same environment. To calibrate your scanner, simply place the calibration plate on the open rugged case and follow the on-screen prompts. Hold the scanner squarely above the plate and slowly move vertically upwards, using the haptic feedback and software interface to help. Finally, sit the plate on its angled slot and repeat the process. The Peel.3 works best in artificial lighting conditions on objects ranging from 10 cm to 3 meters in size. If you're scanning parts with repeating geometry or symmetry, then targets are your best friends. Targets allow the scanner to maintain knowledge of its position accurately, meaning that tracking will be maintained reliably, improving the output mesh. The Peel.3 uses 6mm targets, which are available in adhesive or magnetic versions. With sufficiently complex geometry, targets may not be necessary, but they can make merging scans simpler later on. Targets should be placed as randomly as possible, with a spacing of around 5 to 10 centimeters. If your object has shiny surfaces, then a light coating of evaporating scanning spray to dull the surface can help to reduce noise. Just make sure that you spray before you target. Start scanning by pressing the play button on the touchscreen. Then hold your scanner around 30 centimeters from the object. You'll notice your parts start to appear on the computer screen as surfaces are captured. The green regions of the model indicate that you're holding the scanner at the optimal focal length, while red areas indicate that you're too close and blue too far away. We recommend moving slowly to avoid losing tracking. On average, you can capture an area of 1 meter squared in about 1 minute, depending on the part's complexity. If you're using a turntable, try and keep your hands out of the frame and spin the plate smoothly. If your model contains small holes, change the angle of the scanner to capture the entire edge as completely as possible. The minimum hole size is 3mm for detailed capture. Next up in the step-by-step workflow is clean. First, we'll remove the background by selecting our turntable. Next, you'll have the ability to remove isolated patches, also called noise, and manually height areas of triangles to keep or delete. Various selection tools allow you to highlight the desired areas of your scan quickly and efficiently. Here you can also add a second scan within the same session, which can be merged together later. This enables the part to be rotated so that underside faces can be captured. When creating a second scan, ensure that you capture common surfaces in order for the software to automatically merge the scan based on target positioning. In the alignment step, you can manually rotate the scan and drag the origin as desired. Generally, however, for parts with flat surfaces, this is best done later once planes have been created in Peel.CAD. At the Improve stage, we have additional options to measure distances on the part and clean the mesh to automatically remove any abnormalities. We can also remove holes where open boundaries exist and decimate the mesh to reduce the number of triangles while preserving the geometry. We have a sandpaper tool to smooth out rough surfaces and a sculpting tool to engrave or emboss pathways. We can also edit boundaries to smooth edges or fit to desired shapes and remove spikes and outcropping triangles, giving a full suite of tools to tidy up the scan for the most efficient reverse engineering process later on. If colour scanning was selected, then your model can now be colorized. Finally, we can export the scan in two ways. The first is to save a mesh file, most commonly as an STL, and the second is to export into the Peel.CAD software, a bespoke reverse engineering tool. Peel.CAD is a bridging software, allowing the creation of entities and features which will help to speed up the reverse engineering process. When importing an STL mesh into SolidWorks, a graphics body is created, with no selectable faces or edges. This makes modelling really tricky, as you can only use the scan as a ghost image to trace over. Using the Peel.CAD software allows our 3D modelling workflow to be far more streamlined. We can create points, circles, slots, planes, cylinders, cross-sections, pipe center lines, and silhouettes, and more, generating sketches or solid bodies which can be directly transferred to SolidWorks. We can add auto surfaces or single patch surfaces for organic geometry that may be difficult to model. Mesh triangles can be copied or deleted to focus on particular areas of the scan, and additional improve and edit tools are also available, such as remeshing and defeaturing, as well as cutting, extruding and mirroring the mesh. On the far end, there are tools for combining, merging and comparing meshes if multiple scans exist in separate files. Now that we've seen all that the Peel.3 scanner has to offer, stay tuned for part 2, where we'll walk through the full reverse engineering process using SolidWorks CAD software.